Hey guys, welcome back. So now that we're clear with the basics, we can go ahead and solve a problem. So in this question, they've asked us to draw an ellipse where the distance between the directrix and the focus is 57 millimeters and the value of the eccentricity is 2/3. So O is basically the point where the directrix meets the axis, so OF is equal to 57 millimeters. Eccentricity is equal to 2/3, which is also equal to VF divided by OV. VF is nothing but the distance between the vertex and the focus, and OV is the distance between the O and the vertex. We have learned this in part 1. So VF divided by OV is equal to 2/3. So there are 2 parts of VF and 3 parts of OV. So in total, there are 5 parts. Now we can move on. Right here, this vertical line is the directrix. This horizontal line is the axis, and I'm going to measure 5.7 centimeters and mark my focus. This is my step 1. Step 2. I've got 5 parts, so I have to divide OF into 5 equal parts. So what I'm going to do is I'm just going to draw a random line in between the directrix and the axis. Just a random line, it can be of any angle, right? So that random line, because I have to divide OF into 5 parts, I'm going to take it in multiples of 5. I can take 5 centimeters or I can take 10 centimeters. Divide it into 5 equal parts. This is my second step. So just to be clear, I'm just going to draw an extra line in between the directrix and the axis, because VF plus OV is equal to 5 parts. I'm going to take the measurement of this line in multiples of 5. So if I take 5 centimeters, I'm going to divide it by 5. If I get E is equal to 3/4, for instance, and the number of parts will be equal to 7. So this extended line, I'll draw for 7 centimeters or 14 centimeters divided into 7 equal parts. Get it? Right, this is my step 2. Step 3. My last point on the extended line, I'm going to connect it with my focus. After that, I'm going to use my drafter, right, and connect all the points on the extended line with the axis, making sure that each and every one of these connected lines are parallel. This is my step 3. What do I get with this? Well, I'll be able to divide my OF into 5 equal parts. Because my OF is a random number like 57, right? It's not a nice number like 50 or 60, which I can easily divide with a ruler, right? It's 57, so instead of taking the effort of taking like decimal points and stuff, this is the best method. Take a random line, divide it into equal parts, draw parallel lines to the axis, and you'll get it into 5 equal parts. So basically, if you draw this properly, right, you'll get 5 equal parts of OF. Now step 4. Using my E is equal to 2/3, I'm going to divide my OF, right, into the VF and OV. So 2 parts of VF and 3 parts of OV. So this is my vertex. And I'm just going to draw a straight line through the vertex. Once I've done that, I'm going to take VF as the radius, V as the center, and draw an arc so it intersects the line V. Right? I'm going to take VF as the radius, V as the center, and draw an arc so it cuts the line V. And that arc I'm going to join with the O and extend it further. This is my last and final step. Right, so basically first I'm drawing my directrix, my axis, taking 5.7 centimeters. This is my first step. Second, I'm just going to draw an extended line in multiples of how much ever parts I'm getting. For instance, here we have total parts is 5. I'm going to take in multiples of 5 or 10. 5 multiples of 5. and then I'm going to divide it into 5 equal parts. The last point, I'm going to join it with F, and I'm going to take parallel lines joining the axis, so I get 5 equal parts. Then I'm going to mark my vertex and draw a straight vertical line through it. Then I'm going to take VF as my radius, V as the center, and draw an arc cutting the vertical line V, and that cutting point and the O, I'm just going to connect it and extend it further.